So now let's talk about moving decimal strategy. Maybe a lot of you heard about the moving decimal strategy, and then whenever you have a decimal problem, probably you use moving decimal strategy for most of the time. For example, so if you have a problem like this, what do? A lot of them you move decimal like this, and you do 12 times 14, which is 8, 4, 2, 1, 168. And what do we do next? Because I moved decimal strategy there, so I'm going to move the decimals back to place like this. So my answer is 1 and 68/100. So this is probably we use this. We call them moving decimal strategy. But have we thought about why it works all the time? Why we are doing this? Why it works? Why is that? And what about the division problem here? You have a division problem there. Also, I'm going to show you. Okay. What do? We move the decimals like this. So change 2 and solve the problem. That's what we do, right? Let's do how many times 25 go into 75? 3 times. Let's do the traditional way. So it's 30. Good. So now, this is 30. And we moved decimals twice here, but we didn't move it back. The answer is 30 for this one. You can check with your calculator. This is it. We don't have anything like move back to here, so my answer is 0.3 or 30/100 or something. We don't do that for division, but we do for multiplication. Why is that? Have we thought about that? Why we move decimal back here, but why we don't do for this division problem? Why is that? That's what I want to think about it. What does moving decimal strategy mean? How can you move decimals? Remember that the decimal place value met, we didn't move the decimals, right? Decimal doesn't move. Decimal do not have legs. They don't move. We move the numbers. Using what? We move the numbers using power of 10. So we make it bigger using multiply by 10. We make it smaller by divided by 10. That's what we did. We used power of 10 to change their place value, but we didn't move the decimals. Okay? So moving decimal strategy means actually we are not moving the decimal. We are doing changing their place value, number place value, by either by multiply by 10 or divide by 10. That's what we are doing. And that's how we mathematically work. So here I want to show you an example here. So I want to do 4/10 times 6/10, right? So what did they do here? So to change my decimal to a whole number, I multiply 10 2 times, right? So because I cannot change my value. Can I change by value? Because I need to add 5 plus 6, but I don't want to do it. I want to change 6 to 5 because I know I love the doubles. So my answer is 10. No, we cannot do it. If we change 6 to 5, you have to add 1 back to the original number to make it balance, right? We will talk about the balance. Same thing in here. So we cannot do it. So we change to here, the whole number, but we multiply by 2 times. We have to divide them by 2 times to make it even, make it balance from the beginning where we started. That's why we have to multiply and then divide by 10 here. So I'm going to talk about, so like this. How can you change to that? We multiply a number by 10. And how can you do that? We multiply by 10. We didn't move decimals. I multiply numbers 10 and 10. So 4 times 6 is 24, but I multiply 2 times. I have to divide the number by 100. So my answer is 24 hundredths. So this is why moving decimal strategy by so-called people say works. But we don't teach this and just show the process. That's why it causes a lot of confusion. If they don't know why it works all the time, they don't know what number, where my decimal place should go, because I have no idea. I just follow the rule. So we're trying to teach them with the conceptual understanding. Does it make sense, this one in here? Then why not? Why we don't do the same thing for the division? Have you thought about that? So division, we don't do it. We just change the whole number. That's the answer. How that is possible? And this is why. So let's do the division problem here. 1 divided by 2 tenths, right? So remember that we talk about that division is fraction. Fraction is division. So I want to change in this one into fraction problem. Are we good? So this is 1 divided by 2 tenths. Same thing in here. And I want to change this to whole number because I don't know how to do this. I don't want to do the long division. It's too difficult. If I do like this, it's going to be too difficult. I have to do long division. Okay, so I don't want to do it. Then, so I want to change it to whole number. So I can multiply 10. So I'm going to make it so I can change it into like this. Now I can do it. I think I can do 10 divided by 2, which is 5, right? I can do that. That's 5. But we don't need to go back to decimal, something like this. Why is that? Because remember that when you're talking about the fraction, if you multiply, do the on top, you have to do the same thing to the bottom. Otherwise, we are going to change the original numbers. So this one, 10 over 10 is what? 10 over 10 is same as 1. So anything multiplied by 1 is the self. Doesn't change any value. That's why we can do this, because we didn't change any value mathematically. We just changed the place value by multiply by 10 over 10. So that's why this is 5, and we don't need to change anything. So here, originally we are doing this, so we're going to change it to 10 divided by 2, and the same as here. We don't need to back to any decimals here because we didn't change any value. We just multiply by 1. Does it make sense? So same thing in here. The problem I showed you earlier. Seven and 5/10 divided by 25 hundredths, right? So if we want to do long division, we are going to move decimals, so we're going to change to different number. But we can do it here. So I want to do 100 over 100 is what? It is 1. So actually this is not change any value. So I can do 750, and this one is 25. So my problem is going to be same as whole number. So I don't need to change anything. And this is why mathematically we are working on the division strategy. Okay? That's why I want you to think about it too. And also, whenever I always think about the decimal number sense, we're going to do slides about decimal number sense. And think about that. If you have this number is smaller than this, we always talk about that, your answer is going to be bigger than 1. This one in here, think about that, how many times this one goes to here. When you look at this here, what about if this number is 1? How many times 1 go into 7 and 5/10? At least 7 times. But this number is way smaller than 1. So it has to be much more than 7 times, right? Like 1/4 of times bigger. So if they know those number sense, they can think about that. Oh, I think it's going to be 7.5 times 4. Yeah. They can think about that too. I just can't think about it. So if they have a number sense, they can think about that. What is going to be my answer, right? 30. They can think about it here. Okay. So you can teach moving decimal strategy. Personally, I want them to know that using times 10 instead of using moving decimal strategy. But if you want to teach moving decimal strategy, it's okay. But you have to explain why it works mathematically and what does it mean. When we move decimals, what does it mean? If we move decimals right, what does it mean? If we move decimals to left, what does it mean? Actually, we don't move decimal as you saw the place value math. But if you want to teach those concepts, please make sure that they understand what's going on with my numbers and what we are doing on these operations. That's the important part. Okay? Good.